well, welcome back to our series on expanding and factorizing. We're now going to move on to factorizing, having covered expanding in the last video. I just want to remind you of this phrase called binomial expression, which is two terms added together, basically, because that's what we're going to start off with. We're going to be factorizing binomial expressions. For example, this one, and it has two terms, and we're going to take this expression and separate it into two factors. But I do want to revise expanding, because expanding is the opposite of factorizing. And I'm going to revise expanding using this image, which I think will help us understand factorizing eventually. So remember, if I expand this, I need to multiply these two, and I need to multiply these two and add it all together. So 4 times x is 4x, and then I have to do 4 times 3, which is 12. But if you have a look at this diagram, you can see that this side of the rectangle is 4, and this part of the side is x long, and this is 3 long. So the length of this is x, and that length is 3. So if I want to find the area of this blue rectangle, that's 4 times x, isn't it? Which is 4x. And the area of this, I think it's peach colored rectangle, is 4, because that's this side length, times 3, which is 12, of course. So you can see that I start from 4 times x plus 3, which is this, the two factors, and I end up with an expression which is 4x plus 12. Okay, now we're going to do the exact opposite of that in terms of factorizing. So now I've got the areas in the two boxes, and this whole thing, 7x plus 21, is my expression, and I'm going to go backwards to get the two factors. So have a think about this. What is in common? This side has to have something in common with both this term and this term. And what is in common with both of these terms? It's the number 7. 7 is a factor of this term, and it's a factor of this term. So if I have 7 here, then I have to, this rectangle is 7 times something is 7x, has to be x. And 7 times something is 21. This has to be 3. So, what are my two factors? Well, 7 is one factor, and my other factor is x plus 3. So what did we do here? We tried to find a factor which is in common with both of these. And we actually found the highest number that is in common, common factor of 7x and 21. And then we wrote that down here. And then we tried to find the two numbers that I could multiply with 7 to get these two terms. So the number I could multiply by 7 to get this term is, well, it's not a number, it's x. And the number I can multiply by 7 to get 21 is 3. So that's what we're doing in terms of expanding, factorizing. That's what factorizing is. That's how we separate it into two factors. So I've written down a list of instructions, and if you would like to pause the video and take this down, that's fine. So if you've got two terms, remember we're factorizing binomials, which is the two terms. You find the highest common factor of the two terms, first of all, and then you write that down to the left of an open bracket. So you write it here, and then you've got a bracket. And then you divide each term by the highest common factor and write the results in the brackets. And this is the more exact version of what we already did just then. So let me show you what I mean. Let's do an example. Well, let's do this example, and hopefully it will become clearer as we do it. So first of all, the highest common factor of these two. Now, if you haven't done highest common factor for a while, here's a quick revision. If I've got two numbers, 8 and 12, the highest common factor of these, well, it can help to write factor pairs of each number. So 8 equals 1 times 8, or it equals 2 times 4, or 3 times, no, it doesn't work. So, or 4 times 2, but I've already done it. So that's my favorite way of finding factors. So 12 equals 1 times 12, or 2, so you just go 1, 2, 3, 4, 1 or 2 times 6, or 3 times 4. And if I go for 4, I've already done the number 4, so that means I can stop here. So what I've got here is all the factors of 12, and I've got all the factors of 8 here. And I have to find the highest one, which is 4. The highest factor, which is in both of these, is 4. So that was just an example in terms of finding the highest common factor. But here, we've got two numbers, 4 and 6. And hopefully you don't need to write out the whole thing to work out what the highest common factor of these are. I mean, the factors of 4 would be 1 and 4, and 2 and 2. So 1, 4, and 2. And 4 is not a factor of 6. 1 is a factor of 6, but we just kind of ignore 1 because it's not very useful here. And the last common factor we've got is 2. So 2 has to be the highest common factor of these two numbers. Now, when you get to the x's, there's something that you can do when you're starting out with this that I think is helpful. So you can write out all of the factors, the prime factors of 4x squared, and you can write out all the factors of here, 6x, and then you just circle everything that there is in common. So 2 is the number that's the highest common factor, and x is also part of that highest common factor. So the highest common factor has to be 2x. All right, so long story short, we move on to the next step. We write the highest common factor down. That's 2x. And it says to the left of an open bracket. So let's do an open bracket. And then we have to go to step 3, which is divide each term by the highest common factor. So we divide 4x squared by 2x. So when you divide 4 by 2, you get 2. And you divide x squared by x, you've got x. And if that's a little bit too complicated, you can also think, well, what do I have to times 2x by to get to 4x squared? You have to times 2 by 2 to get 4. You have to times x by another x to get x squared. So now you do the same thing for this. So if I divide 6x by 2x, then I get, if I divide 6 by 2, I get 3. And the x's just cancel out. So that's it. Now that may have been a little complicated. Luckily, we've got another example just to help us eventually come to an understanding of the process of factorizing. So let's go to step 1 again. Find the highest common factor of two terms. So 10 and 15 Now these numbers are getting a little bit big, but there's still not that many factors. Not that many factors of 10. So 1 and 10, obviously, but again, that's not very useful. 2 and 5. So 2 times 5 is 10. So here's some factors. 2 or 5. 3, you can't divide 10 by 3. That's not a factor. Can't divide it by 4. That's not a factor. And now we're up to 5. So it's just these two, actually. The highest common factor will be one of these two. If we can actually find a highest common factor. All right, so what about 15? Well, you can't divide 15 divided by 2 is not a whole number, so it's not a factor. You can divide 15 by 3, because 3 times 5 is 15. So I've got 3, and I've got 5. You can't divide it by 4, so that's it. These are our two factors, and the only common one is 5. So the highest common factor is 5. Now in terms of the letters, x is in this one, but it's not in this one. So x is not part of the highest common factor. Here I've got y squared, and I've got a y. Keep in mind, y squared is y times y. So over here in this term, I've got y times y. And over here, I've just got 1y. So you've only got one y in common, because this y only has this term only has one y, so you can't write both of them in there. You can only write what's the same in both of them. So I can write a y here. And that's my highest common factor, 5y. So I've done the numbers and I've done the letters. Now you write the brackets, the open bracket, and then we divide this, each term, by the highest common factor. So if I divide 10 divided by 5 is 2. Xy squared divided by y. Well, this y is going to cancel out one of the y's in the y squared, but it's not going to do anything to the x. So y squared, one of those y's is cancelled out, so I've only got one y left. And then we'll divide 15y by 5y. 15 divided by 5 is 3. And the y's will cancel out, so I have no y's here. And that's it. Now, hopefully this one was a little bit easier. We are going to move on to a harder example. If this is your limit right now, that's absolutely fine. Stop the video and go and do some questions with some of those simpler binomials, because the questions we're about to get into are definitely, well, it's just another layer of difficulty. It's not too hard, the ones we're going to do, but it's another layer. So if you've learnt just as much as you can learn, then go and do some questions and come back to this video later. All right. So here we come to a particular example which is very different to the other ones, because each term actually has, well, it's like a term with two terms multiplied together, or a term and an expression. So each term, it's not just like 10xy squared, it's two things times together. Now, when we're looking for common factors, this is a very different process. We'll look at x and 5. There's nothing in common with those two. And then we look at this, x plus 2 and x plus 2. In fact, this is the common factor. X plus 2 is the highest common factor. So what I have to do is I write x plus 2 over here. That is my highest common factor. And then I can do the next step and divide each term by x plus 2. Well, if we start off with this one, if I am dividing this term by x plus 2, you can see hopefully that these two terms cancel out. And so all I've got is x here. And if you divide this whole thing by x plus 2, you can see that x plus 2's again are going to cancel out. And I'm only going to have 5 left. And that's it. This is my highest common factor. This is the other factor. By the way, let me just clarify that in this previous example, this is a factor and that's a factor. I've factorized. And in this one, that's a factor and that's a factor. You have to understand whether you're factorizing or expanding. And if you have two factors multiplied together, like this, you've probably just factorized. And you don't need to expand again because that would defeat the purpose. All right, so I've got my two factors. We've just got one more example left to do. And this is just a trickier version of the previous one. So I'm looking for a highest common factor here. Straight away, hopefully you should be able to see that this is a common factor, x minus 1. But, so I'll write this down, x minus 1. But there's another part of this that's common factor because there's actually common factors between this section and this section. So 2 is a common factor of these two terms. And also, I've got an x here, which is common with this because there's also an x here. So my highest common factor is actually 2x times this. This whole thing is a common factor, which is kind of two factors in one. Okay, now I've actually got to divide each side by the common factors, each term. So this term, when I divide this whole thing by this, let me write that out. Well, this is a very hard question. You can see that these two are going to cancel out. And then I've got 8x squared y divided by 2x. 8 divided by 2 is 4. X squared divided by x is x. And y, I've got a y as well. Okay. Now, if I divide this by this, they're exactly the same, aren't they? So if I divide it, everything's going to cancel out and I'm just going to get 1. So that is the final answer. That's a really tricky one. If you don't understand this, don't even worry. You can do some questions and really understand everything up to here. And then if you still don't understand this, you can ask for some help. Now, the last thing I want to say is that anytime you factorize, you can check whether you got it right by expanding again. Now, I don't want you to get confused between factorizing and expanding. What we did here was factorize. So I don't want you to get confused, so I'm just going to write check because you've technically finished the job. You've done it. But you can check your answer by expanding this again. So let's expand it just to check. So 2 times 2 is 4. X times x is x squared. 2x times 3 is 6x. So now we've actually checked it. We've got the same result as we had at the start. So that means we actually did get it right. Okay, so you can check this anytime you factorize, you can check your answer. Okay, I don't have much more to say, except that I just want to remind you that the factor pair thing, if you have really big numbers, like 72 and 30, and you have to find the highest common factor of these, I do recommend doing this factor pairs thing. So 72 equals 1 times 72, or 2 times 36, or 3 times 24. And if you keep doing this, you will find the highest common factor. It will take you a while, but it's one way that's very reliable that will get you the right answer. 4 times, and you can do it on your calculator as well. You can divide 72 by 18. Divide 72 by 4 to work out how many times 4 goes into 72. 72, it can't be divided. If you divide it by 5 on the calculator, you get a decimal, so that doesn't work. 6, though, you can times it by 12. 7 doesn't work. 8, it's 8 times 9. And then, okay, so 8 times, if I go to 9, then I'll get 9 times 8, of course. And so we can stop there. 30 equals 1 times 30, or 2 times 15, or 3 times 10. 4 doesn't work. 5 times 6. And if I do 6, it'll be 6 times 5, won't it? So now, here are all the factors of 72, and here are all the factors of 30. So, what is the highest common factor? Well, if you look for the numbers in common, you've got a 3. You've got a 2. 1s we just ignore. No 4s. No 5s. And we've got a 6 in common. And 6 is the highest, isn't it? So the highest common factor here. Yep. Highest common factor is 6. So if you're factorizing this, it would be 6. And then 72. If you want to divide 72 by 6, you've already written the answer here, really. It's 12. So 12x minus, and you're dividing 30 by 6, you get 5. Minus 5. And that's it. If you want to pause the video and do this sheet, then this helps you to find all the factor pairs of these numbers. I've already done 72, but you might want to do it again if you want to. And there we go. Some of them are impossible. So if you look at 100 equals 9 times, you can just scratch that out if you want to, because that's impossible. Okay, so if you want to pause the video and do this, up to you. Now, I'm going to see you next time for some of the harder factorizing. And when I say harder, it's not necessarily harder, it's just the next level, which is monic quadratics. I'll tell you what that is later. Okay, I'll see you next time.